Welcome to AI News Digest 2026-0626. Today's 9 stories. Story 1, Small Language Models Outperform Frontier AI on Cost, Speed, and Accuracy. Story 2, Detecting and Controlling Sycophancy with Cascading Linear Features. Story 3, Refusal Lives Downstream of Persona in Chat Models. Story 4, Life After Benchmark Saturation, a Case Study of Core Bench. Story 5, The Verification Horizon, No Silver Bullet for Coding Agent Rewards. Story 6, Governing Actions, Not Agents, Institutional Attestation as a Governance Model for Autonomous AI Systems. Story 7, What We Are Missing in Multimodal LLM Evaluation. Story 8, Best AI for Complex Reasoning, 2026, Opus, GPT-5.4 and Gemini. Story 9, Knowledge-augmented Agentic AI for Mental Health Medication Information Seeking. Story 1, Small Language Models Outperform Frontier AI on Cost, Speed, and Accuracy. A new research paper out of Archive, submitted in late June 2026, is tackling a problem that doesn't get nearly enough attention in digital health. What happens when patients with psychiatric conditions go online to research their medications and end up in a confusing mix of clinical warnings and personal horror stories? The paper, authored by Huizi Yu and 12 colleagues, introduces a knowledge graph-based multi-agent AI system, specifically designed to integrate and distinguish between these two very different types of information about antidepressants. Here's the core challenge. When someone is prescribed sertraline or escitalopram, they often turn to Reddit or WebMD to understand what to expect. But those platforms exist in a completely different world from FDA adverse event reports. The FDA data is authoritative but abstract and hard to parse. The patient stories are emotionally resonant but unvalidated. Mixing the two without context can trigger what researchers call the nocebo effect, where fear about side effects actually causes patients to experience or anticipate those side effects, and ultimately stop taking a medication that might help them. To address this, the researchers built a system that unifies 466,525 Reddit posts, 60,782 WebMD reviews, and 20 years of FDA adverse event reporting system records across 9 antidepressants. A large language model pipeline extracts medication and condition mentions from all of this text, achieving near-perfect accuracy, F1 scores of 0.969 for medications, and 0.973 for conditions when benchmarked against physician annotations. Everything is stored in a Neo4j knowledge graph anchored to standardized medical vocabularies, so every claim in the system is traceable to its source. One of the most striking findings is about timing. For sertraline, adverse events showed up in community sources, Reddit and WebMD, hundreds of days before they appeared in official FDA records. This suggests patient-generated content could serve as an early warning system for drug safety signals, a complement to formal pharmacovigilance channels that are known to be slow and underreported. The framework also found that Reddit and WebMD data were highly concordant with each other, showing Jacquard similarity scores as high as 0.905, but much less aligned with what regulatory reports captured. This suggests these patient communities are generating a partly independent, internally consistent safety signal worth paying attention to. The team is careful to note that this is a proof of concept. Prospective testing on real patients hasn't happened yet, and the system currently covers only 9 drugs. But the implications are significant for pharmacovigilance, for patient education, and for any health information platform trying to provide trustworthy, contextually appropriate medication guidance in the mental health space. Story 2, Detecting and Controlling Sycophancy with Cascading Linear Features. As multimodal AI models have raced forward in capability, the benchmarks we use to measure them have been left far behind. That is the central argument of a new analysis from researchers at Archive, and it is a problem with real consequences for anyone making decisions based on published model rankings. The paper, authored by Po-Han Lee, Shenghui Chen, Sandeep Chinchali, and Yufuk Topku, takes a hard look at the current landscape of multimodal large language model evaluation. That is, how we test models that can process text, images, audio, and video. Their conclusion is that most existing benchmarks are fundamentally limited to isolated single-modality tasks. They show you an image and ask a question about it. They play an audio clip and ask what was said. But they do not ask whether the model can actually integrate information across those different modalities in the way a person would. The researchers identify 4 specific gaps in current evaluation coverage. First, temporal spatial coherence. Can a model track how objects and scenes change across time in a video? Second, physical world understanding. Does the model have genuine grounding in how the real world works, or is it just pattern matching on training data? Third, multimodal consistency. Does the model give the same answer when the same information is presented as text versus as an image? And fourth, selective attention. Can the model correctly identify which part of a complex multimodal input actually matters for answering a given question? Why does this matter beyond academic benchmarking? Because organizations buying and deploying multimodal AI systems are making decisions based on leaderboard scores that, according to this analysis, do not measure the capabilities those systems actually need in production. A model winning on current visual question answering benchmarks may completely fail at tracking object relationships in a surveillance video, or at maintaining consistent interpretation across a mixed text and image medical document. The researchers are not just pointing at a problem, they are providing a roadmap. By naming and defining these 4 evaluation dimensions with precision, they are laying the groundwork for the next generation of benchmarks. The field now has a clear checklist for what needs to be built, and until those benchmarks exist, practitioners should treat published multimodal benchmark scores with significant skepticism when applying them to real-world use cases that demand genuine cross-modal reasoning. Story 3. Refusal lives downstream of persona in chat models. Not every important signal in the AI space comes from a research lab. Sometimes a commercial blog post tells you as much about where the industry stands as a peer-reviewed paper. This piece from Team AI, a business-focused AI workspace platform, is a buyer's guide to the best AI models for complex reasoning in 2026. And even though we cannot see the full content, what is visible reveals a lot. First, the model names themselves are telling. The comparison features Claude Opus from Anthropic, GPT-5.4 from OpenAI, and Google's Gemini. That reference to GPT-5.4 is significant. It implies OpenAI has released at least 4 versioned iterations of the GPT-5 family, suggesting either a rapid capability improvement cycle or a strategy of incremental feature releases to maintain market momentum. The naming conventions of frontier models are becoming as complex to track as smartphone generations. Second, the sheer scope of Team AI's content operation is a market signal in itself. Their blog references comparisons across 22 different frontier AI models for 2026. That is a staggering level of market fragmentation compared to just 2 or 3 years ago, and it creates a real operational challenge for enterprise buyers who need to choose the right model for the right task without a PhD in AI to guide them. Platforms like Team AI are filling that gap and profiting from it. Third, the focus on complex reasoning as the key evaluation dimension reflects where the competitive battle has moved. Text generation and summarization are largely commoditized. The 2026 differentiator is multi-step analytical reasoning, agentic task completion, and logical problem solving. Enterprise teams are asking not just whether AI can write a good email, but whether it can work through a complex business decision or debug a multi-step workflow. The caveats here are real. This is vendor content with a commercial interest. There is no publication date, and the actual comparative methodology is not visible. But as a reflection of how enterprise AI purchasing decisions are being framed and communicated in mid-2026, it is a useful window into the market. The AI tools conversation has matured from individual productivity to organization-wide strategy, and that shift is clearly visible in how platforms like this one are positioning their offerings. Story 4, Life After Benchmark Saturation, a case study of Core Bench. This paper argues that retiring saturated benchmarks in favor of harder replacements misses critical evaluation dimensions beyond accuracy. Using Core Bench as a case study, authors examine construct validity, out-of-distribution generalization, efficiency, reliability, scaffold versus model contribution, and human-agent collaboration uplift. Story 5, The Verification Horizon. No silver bullet for coding agent rewards. As coding agents become more capable at generating complex solutions, the paper identifies reliable verification as the new bottleneck, harder than generation itself. The authors show that every automated verifier is only a proxy for human intent and explore the fundamental limits of reward specification for coding agents. Story 6. Governing Actions, Not Agents. Institutional Attestation as a Governance Model for Autonomous AI Systems. This paper proposes a governance framework for autonomous AI agents inspired by how human institutions govern powerful actors, by requiring independently attested evidence at consequential decision points rather than monitoring internal reasoning. The model is formalized computationally and applied to high-stakes domains like clinical prescribing and software deployment. Story 8. What we are missing in multimodal LLM evaluation. This paper critically examines current multimodal LLM evaluation benchmarks, finding that most are limited to isolated single-modality tasks and fail to assess whether models genuinely integrate information across modalities like text, images, audio, and video. The authors survey existing benchmarks and highlight evaluation gaps that need to be addressed. Story 9. Best AI for Complex Reasoning, 2026, Opus, GPT-5.4 and Gemini. A comparative benchmark analysis of leading frontier AI models, including Claude Opus, GPT-5.4 and Gemini, on complex reasoning tasks, with a focus on ARC-AGI-2, a benchmark specifically designed to resist pattern recall and test genuine abstract generalization, provides practical guidance for selecting models for high-reasoning workloads. Story 10. Knowledge-augmented Agentic AI for Mental Health Medication Information Seeking. This paper presents a knowledge-augmented agentic AI system that integrates authoritative regulatory adverse event records with patient narratives to provide safer psychiatric medication information. The system is designed to avoid conflating anecdote with evidence, addressing real risks of nocebo responses and non-adherence from poorly contextualized online health information.